The marks have been posted. Um, Overall, across the three grades, indicated last class for the most part, the marks went north. Not 100% of the marks, but the general trend was an improvement. I'm gonna give the test back and go through them. It won't take the whole period. So the balance of the period, I think probably the best usage at that time would be at least doing enough of these that you are sure you're doing them correctly. If you're not sure, ask me. But given the time today and the fact that I don't see you guys till Monday, I think I'll make this thing do for next class. And there will be time to work on it today. I don't know what's wrong with my computer. There it is. If, as is always the case, if you notice anything wrong or that you think is wrong with your test, if I added something wrong, can't understand the mark I gave you or why I gave it to you, can't understand my writing, wait till I've gone through everything, and then if I owe you marks, I'd be happy to give them to you. It's just wait till we're done everything. We'll start with the multiple choice on the screen, and then we'll do the written response. Test was out of 50. The first mark that you're seeing is the mark out of 27 on the written response. And the second mark is the mark out of 23 on the multiple choice. And on the Scantron form you get back, if there's a square around it, it means it was a wrong answer, and then the correct letter is next to it, which you'll be able to make sense out of once we go through the multiple. These are in no particular order. Mine, Lauren, Claire, Daniel, King, Nicole, Samantha, no, Allison, Christina, Sandra, Ariana,
She's gonna be late.
sorry,
She's gonna be late. She's on.
okay. The other Samantha, Randall, Daniel,
Thank you.
Alexandria, and else, Craig, Dickus, Julia, Leah, Brienne, Olivia, Annika, Julian, and Michaela's not here either.
Wow.
Oh,
It's not one.
give me a sec.
Oh, thanks.
Some of these are marked, I mean, it might, so it's not writing, here's the legible, it may be, it looks illegible. Lauren, you're lost, coming from the,
No, sir, I was cleaning after a club meeting.
what?
I was cleaning after a club meeting. It's for poster club.
Why do you have to clean up after? A
It's like all pink, so I had to clean the paintbrushes and stuff.
Just you?
Yeah, that was like my job.
Okay. Yeah.
No, you know, not bad. I see. Sure, because can be man.
So let's do the multiple choice.
Total
Really slow down the high score, but if I turn the slide out, we would be. We'll see.
and need not look clear.
It won't be a bit tough to see if you're in the back, but. First question was about really the biggest distinction of the matter map. Matter can be divided into which the following two categories: pure substance and density. Number two, the paper chromatography experiment, the solvent front has traveled 20 centimeters. The solvent front's D2. Okay. How far would the solute have traveled if the RF value was 0.6? What that means is the solute moved 60% the distance that the solvent did. So D1 over D2. So you're looking for D1, D1 from RF for D2, which is 1. Compared to a solution of salt water, a sample of pure water will boil. What I saw some students do, which is a really good idea, is just sketch. So there's pure water. So 100 and 0, and salt water. So compared to a solution of salt water, a sample of pure water will boil at a lower temperature, freeze at a higher temperature. Now, you may not have been able to recall that directly, but if you need to draw a diagram, draw it. I'm not marking anything on the multiple choice question sheet. You can write anything on there that you need. And all I wrote here was recall heating curve. You might have noticed as you were writing the test, and if you don't, I'll inform you over the course of this discussion, is that a lot of the questions I asked are intentionally questions that were referencing things I added or focused on. Not just how I changed the heating curve, but some of the discussions in terms of metalloids. All of it, again, should convince you of the benefits of taking notes, okay? Concerning the states of any given sample of matter, I added this to Gary's diagrams. Which of the following statements is true? The answer is A. Particles in the gaseous phase possess the most potential energy because the attractive forces have been completely overcome, and the most kinetic energy because they are free to move. And that's one of the things we added to the diagram as we add heat, going from solid to liquid to gas. As temperature increases, the conductivity of a metalloid increases, whereas the conductivity of a metal decreases. And again, I added that to what Gary had given us, but we did it by temporarily going to chapter 6 and looking at what it is about metalloids. Why do we call them that? Why don't we just call them metals? Okay. Next one looks a little crooked. My apologies. As components of a mixture separate while moving along a sheet of chromatography paper, remember we added that one of the unique things with chromatography is, compared to the other separation techniques we talked about, was that chromatography depends on two different physical properties. The solubility of the components in the carrier phase, the mobile solvent, and how well they stick to the stationary phase. So, as components of a mixture separate while moving along a sheet of chromatography paper, the more soluble the components of the mixture are, the further they move. If what's moving them requires their dissolving in it, the more soluble they are, the more they're going to move. C and D are referring to the next property, how well it sticks to the stationary phase. So if you look at the ones that are wrong, the less the components of the mixture adhere to the paper, the less they move. Well, that doesn't make any sense. If they don't stick to the paper, the more they're going to move. C was also backwards. The more the components of the mixture adhere to the paper, the further they move. That doesn't make any sense either. If they stick to the paper, they're not going to move better. And in A, the less soluble the components of the mixture are in the developing solvent, the further they move. Well, if they don't dissolve in what's moving them, they're not going to move very far. So A, C, and D were backwards. But once again, that's additional stuff we talked about. Solvent extraction will separate components of a mixture based on different solubilities. Gold panning and centrifuge will separate components of a mixture based on their densities. Filtration will separate components of a mixture based on their size. Which of the following compounds would require Roman numeral to be included in its name? We need a compound with a multivalent metal ion. And the only one in that list is here. Magnesium and aluminum metal cations, but they're not multivalent. And that's a covalent compound. But iron is either 2 or 3 plus, which means we need a Roman numeral. For which of the following compounds does the term molecule not apply? That's another way of saying which of the following are ionic. Remember, I dictated that to you. It began with, in ionic compounds, no neutral independent molecules exist. That's why the formulas are ratio. So this just means an ionic compound. There's the ionic compound. D, B, and A are clearly molecular. Okay? Kind of in a similar vein. Which of the following compounds is likely to exist as separate molecules? Not all covalent compounds are molecular, but most are. So ionic, no molecules, but also 3 different electrical compounds. The formula for the compound iron 3 dichromate, that could have been a grade 9 question. 2 irons equal 3 plus, cancel the charge on 3 dichromate equals 2 minus. The compound is ZnC2O4 bracket 2, that's thin 4 oxalate. Each oxalate is 2 minus, and the 2 of them, which means the cation charge is 4 plus. Use your knowledge of simple and polyatomic ions to decide which of the following formulas is incorrect. You don't really need to rely on your knowledge, just look it up. Aluminum and sulfate, that's a correct formula. 2 3 plus cancels 3 2 minus. Magnesium oxalate, 2 plus cancels 2 minus. Ammonium nitrate, 1 plus cancels 1 minus. If that formula is incorrect, the barium is not 3 plus, it's 2 plus. Or phosphate's not 2 minus, it's 3 minus. The correct formula would be Ba3PO42. Which of the following pairs of formulas shows a cation with 2 different charges? D. Zinc is 2 plus in both of those. Iron is 3 plus in both of those. Aluminum is always 3 plus. But PbO2 is lead 4 oxide, whereas the compound on the right is lead 2 acetate. Number 17, probably the ones you had to be sharpest on of the questions. We were talking about the fact that, and I used the model kit to answer this question. How is it that it takes 800 degrees Celsius to break down the ionic bonds in a solid crystal lattice of an ionic compound, but yet you throw it in water and water pulls it apart at room temperature? And that led into a discussion of the fact that most of you is water, but it's not pure water. It's a solution with mobile ions. And mobile ions is how nerve impulses are transmitted, because unless there's mobile ions, there's no conductivity. So that's what this question was about. Which of the following liquids would you expect to conduct electricity best? There has to be mobile ions. There isn't in bromine, water, or this covalent compound. It's glucose. But there is here. Potassium chloride. If you've got charges that can move, you have a conducting solution. And next page. In which of the following pairs of substances do you see an incorrect formula? You can't really see that because the circle kind of covered it, but that's an incorrect formula. There's no such thing as copper 4 sulfide. There's copper 2 sulfide, and there's copper 1 sulfide, but there's not copper 4 sulfide. Which of the following atoms would you expect to form anions with a charge of 2-. It's another way of saying the following needs 2 electrons to be like an aerosol gas. Arsenic needs 3. Astatine needs 1. Cesium doesn't need any. It's going to give them away. But tellurium is an oxygen group. Just like oxygen needs 2 to get the neon, tellurium needs 2 to get the xenon. And that was based on another dictation, except where large ionic charges result, greater than plus or minus 3. Atoms of the elements will tend to give up or gain as many electrons as are necessary, require the electron configuration of the aerosol gas. How many atoms are represented in the following formula? Again, this could have been a grade 9 and 10 question. 1 nitrogen, 4 hydrogen, that's 5 times 3 is 15, 16 and 4 is 20. Which of the following is not a property of metals? When we were referred to chapter 6, there were a number of bullets associated with properties of metals. And you may recall that the last one was a chemical property, and it says tend to give electrons away in their chemical changes. In other words, they never form negative ions. They're malleable and ductile, they're shiny when freshly cut, and their conductivity decreases with temperature. With metalloids, the conductivity increases with temperature. But they certainly never gain electrons. You're never going to find a metal atom. In which regions of the periodic table are the most reactive elements located? Most reactive metals are far left, most reactive nonmetals are far right. So families 1 and 17. The most reactive alkali metal is on the bottom left. The most reactive element period is top right. So lower left, upper right. Which of the following elements is not a metal? Astatine. It's a halogen. I think Gary may have called it. It's a straight up halogen. It's not conductive. It's a dark brown, very dangerous brittle solid, black, but we don't use it in chemistry because it's dangerously radioactive. Plus, there's only 1 ounce of it on the entire planet, so most chemists have never seen it. Anyway, that's the multiple choice. That was look at the response. Identify which separation technique would be most appropriate to separate the components of each mixture below by matching the number from the column on the right with the mixture described on the left. Solid mixture of 99% 0.5 calcium bromide and 0.5% lithium chloride. That's recrystallization. That's number 6. Table salt mixed with finely ground glass. Solvent extraction. Table salt dissolves in water, glass does not. Finely divided iron mixed with sand. I gave you a clue there, that's number 2. Iron's magnetic, sand clearly is not. Sand and water, filtration. Green dye, everybody should have got that one. Number 3. Potassium chloride dissolved in water, they have to be distillation. So 6, 5, 2, 1, 3, 4. Each of those were worth a half. That's why it's worth 3. Questions 2 and 3, once again, could easily have been a grade 10 question. Vanadium 5 monohydrogen phosphate. Well, vanadium isn't on your table, but you're told what the charge is. So if it's 5 plus, monohydrogen phosphate is 4 minus. So it's that. Monohydrogen phosphate is 2 minus. Strontium hydrogen oxalate, also known as binoxalate. Strontium is 2 plus, not because it's on the table, but because it's in the same family as the metal cations that are on your table. If it's 2 plus charge. Hydrogen oxalate or binoxalate are the 1 minus charge. So you need lanthanum dichromate. Lanthanum isn't on your table either, but it's 3 away from the nearest noble gas, so it's got a 3 plus charge. So it would be La2 and 7. A number of people wrote when they saw dichromate, whereas they forgot that you don't use di. And they put 2 there, and they went, oh, that's a 2, that's a 2, so it's just LaCrO4. So obviously it's incorrect. And unfortunately, there are no part marks for formula writing a name. There's only one right way to do it. There's a bunch of wrong ways, but if you spell something wrong, or if the subscript's wrong, or if you don't put brackets and you should, or if you should or shouldn't, that type of thing, it's wrong. Manganese 4 thiocyanate. If notice it's manganese, not magnesium. So thiocyanate is a 1 minus. If it's 4 plus, we need one of those. Nickel 2 sulfate, hexahydrate. No brackets around the sulfate. You do need the dot there. Hexa means 6. Sodium carbonate decahydrate. Once again, no brackets. And permanganic acid, a per 8 ion makes a per 8 acid. So now you could have written AQ if you wanted to, but I just accepted the default. 7 marks. And just in the same way you expect to write formulas for names, we expect to write names from formulas. I'll just read them to you because I'm lazy. 3A is tetraphosphorus, either deca oxide or dec oxide. Dec oxide is more common, but the fact that it's a covalent compound, you got to indicate how many of each atom there are in the binary formula, because the formula is an ratio. B is also covalent, dichlorine heptasulfide, not septasulfide. And sulfide with pH or an F, it doesn't matter. C, lead is multivalent. If there's 2 dichromates canceling the charge on 1 lead, that's lead 4 dichromate. Similarly in D, that's tin 4 hypochlorite. E, ammonium, either hydrogen oxalate or ammonium binoxalate. Long name for F. Sodium monohydrogen phosphate heptahydrate. Don't put a space between like the monohydrogen and tetraphosphates. That's just one word. And G, thiocyanate is an 8 anion. 8 anions make ic acids, so that's thiocyanic acid. 7 marks again. 2 and 3 added together was more than half of the marks for the written response. All you had to do is really just remember your formula writing name from grade 10. The first sentence in number 4, as I said I would, was taken verbatim off follow-up question in the lab. A pharmaceutical chemist runs a chromatography test on a substance and identifies 2 of its components by comparing their RF values against certain standards. Precisely what you guys did in the lab. Component 1 has an RF value of 0.75. Component 2 has an RF value of 0.6. So clearly, component 1 was ahead of component 2. If component 1 moved 18 centimeters, and that's D1 for component 1, how far did the solid front move? And what was the separation distance between the 2 components? Well, 2 marks each. So RF of component 1 would be how far the component moved divided by V2. We know this, calculating that. And V2, which was carrying both components, has to equal D1 divided by RF. So we're told that component number 1 moved 18 centimeters. And we're told that RF for 1 is 0.75. So obviously you're going to get a number bigger than 18, and we do 20.7. Should be the 2 safe things. If you use the equation I gave you for separation distance, it begins with D2. So the separation distance equals D2 times RF of 1 minus RF of 2. Now this isn't the only way. Once you find how far the solid moved, you could use that to find how far D2 moved and then just subtract it. So this isn't the only way to do it. So you found D2, so that's 24 centimeters. RF of 1 is 0.75, RF of 2 is 0.60. So we have 0.75 minus 0.60, which is 0.15. 24 centimeters times 0.15 is 3.6. Once again, 2 safe things, 2 each. And the last question was about heating curve. And instead of axes below gets a temperature versus time heating curve for an impure sample of ice contaminated with sodium chloride at minus 40 degrees Celsius. As it's heated, melts, and eventually boils. Label on the curve where the phase changes begin and end. So this was taken right off the extra part of the graph that I went to do on the page. And notice that in the question, you're heating and cooling the same solution. There's the landmark. You want to start at 1, 2, 3, 4. You want to start at negative 40. So if this is where pure ice melts, the melting has to both begin and end, obviously lower than 0. You start at minus 40, something like that. Okay? You got a solid here, you got a solid liquid there. Melting begins, melting ends. When melting is over, it has to be obvious to me that you're still below 0. If it's really close, or if it crosses 0 at all, I probably drew this. Okay? Arrows in the down direction. In other words, that's too high. Or if you didn't do this and I couldn't tell, then I probably put arrows down. So that's the melting part. Boiling part has to be clearly above 100. Those of you that did that dotted line made it real easy for me to see that you knew it should be above here, below here. So solid liquid liquid, I didn't ask you to indicate liquid gas. But going to the ends, now you just got gas. So that's half of it. The second one, on the same set of axes, sketch a cooling curve for the same solution. Starting at 100. It's still liquid at 100 because it doesn't boil until above 100. All you should draw now is effectively the mirror image of this because you're cooling the same thing. Where they cross didn't really matter, but the melting, the freezing had to begin where the melting ended. So it should look, again, virtually a mirror image. And then I asked you to go down to -4. So really, this should just be the reflection of that. And if they didn't match, I probably wrote these should match. But again, it has to start freezing well below 0 and go down well. Freezing, liquid, liquid solid, solid. All right. 6 pointers. If the temperatures over which the phase changes occurred weren't clearly below 0 or above 100, you probably lost marks. If you didn't label when what was liquid, liquid solid, solid, if you didn't show where the phase changes started and ended, then you might have lost a half a mark, that type of thing. But remember, Gary did none of this. We added this to it. And that's, again, there's the benefit of taking good notes. There's no such thing as taking too many notes. And even if what I'm saying when I'm teaching makes perfect sense to you, and you don't think you're ever going to forget it, you will. There's just too much to remember. So writing it down helps you remember it. So ideally, that should add to something close to 50. And there were 1 or 2 people which were big. But regardless of what it added to, if you think it should add to more than it did, if you don't understand my writing, if you think you should have gotten more marks than I gave you, if you could make a legitimate case for that, by all means, come up and make a case. And if it's justified, I'll change the number. Whether or not I made a mistake or whether or not you have insufficient test, I still report to it. Okay? But don't turn it in until you're convinced that the mark on there is correct. But yeah, that didn't take the whole period. So we've got about a half an hour for you guys to do nothing but work on this. And I might suggest maybe doing 1 on each page, so that when you leave today, at least you know that everything you're doing is correct. When I look at this on Monday, I'm not going to mark it for correct answers. I'm going to mark it for if you're doing it the way I showed you. This is not really a rigorous worksheet on 6 phase. I'm not too concerned with 6 phase. I'm just concerned about the conversion process. And if you're not sure if what you've done is what you should do, look at the example I did on the last class, and we'll come up with it. And I'd be happy to say yes to that. But I need your tests. By the way, the report card you're getting tomorrow will not have this mark on. So, because I think not everybody, but most people's mark went up. If your mom or dad looks at your report card and it's like, I wish this was higher, you might be able to say, well, it's a power school up, because it might very well be higher. The average on this test was better than the average in the first one.
Just hit it off.
Keep them open to choice.